That's 9 and 10. It's I to the 47, and then number 10 is 1 over I to the 58.
Number 2.
All right, let's just go over a quick review of what I is.
Square
Yeah, well, if we have x squared plus 1 equals 0, if we were going to solve that, and you guys all know, what that function looks like. Does everyone know without even just, thinking about that, what that looks like? Can you describe what does that look like?
parabola.
Where?
1 up from there.
Up 1, pretty easy, right? And this is saying, when does this equal 0? What's the answer?
Never.
Never. Do you guys agree there are no real answers there, no real numbers? So what mathematicians decided, well, geez, we could, if you were solving that, when you guys go like that, bring that over, and then what would you do?
Keep the square root.
Reverse both sides, and you'd get a plus or minus, right? And so we'd have x is plus or minus the square root of -1. And so we decided, or mathematicians decided, that square root of -1 is an imaginary number. Kind of cool that it's imaginary, because it doesn't cross the x-axis, so it's just imaginary. So they decided to make that I, which is on your calculators somewhere, and everywhere you can use. Okay, so that's the square root of -1. And then, when we were trying to figure out what, I'll write it like this to the right. So that's what that is. So instead of writing, when you see the square root of -1, you're not going to write that, you're going to write I. And then I squared is, we use our rules of exponents, I times I, right? When you add the exponent. And that would be root -1 times root -1. And what's that?
So it's
-1, right. So remember I say square root of Andrew times square root of Andrew is Andrew. So there we go. So that's -1. I cubed. How are you going to change that to help you figure out what I cubed is?
So it's square root of
I squared.
I squared times I, because we need 3 of them.
So it's
I squared we just figured out. So this would be -I. Yeah? Get it?
Wait, what?
This is -1.
yeah.
So it's just times the I. I we leave as I. We like I. We just leave it as I. We don't leave I to the, 3012 or something like that. We change it, but we leave I as I. And then I to the 4th, how are you going to change that? I squared times I squared is what Aaron wants to do. I squared, so this would be -1 times, which is 1. And then you'll see, if I go I to the 5th, how do you want to change that? 1. You could do I cubed times what? You could do that.
I to the 4th times I.
That one might be better, but we could do this too, couldn't we? Okay, so I cubed, let's see, I cubed was -I, and I squared is -1, so that is I. Or you could have done what Erin was saying, she wanted to do this, which is true as well, right? You add the exponents, and that one might have been better, because I to the 4th is 1, so this is just I. Positive I, see? Came out the same.
And then it just goes.
So it doesn't matter how you did it. So then it's just going to start repeating itself. So basically the only ones you really need to know are these ones. And this is really important, that I to the 4th is 1. Okay? You go into a store and you say, I'll have I to the 4th loaves of bread. It's just 1. Okay? Another way of saying 1.
Wait, so it'll just start repeating that pattern?
Yeah. So I don't know if I'd memorize the pattern. What I would do is remember that I to the 4th is 1. That's a good one, right? Because 1 times anything is itself. So then when I was going to do I to the 47th, do you guys agree there's tons of ways to make I to the 47th be some sort of I times another I?
Yeah.
Yeah? There's a ton, right? So let's pick I to the 4th. And raise that to a power, because when you raise a power to a power, you multiply. So what do you want to do? 4, how many times? 10 would be, okay, Victor wants to go 10, that's 40 of them.
11.
Then how many more do I need? That's okay, you could have done it, right? You want to do more than that? Want to do 11?
Yeah.
Let's do 11. So that's, now I have 44 I's. How many more do I need? 3. So this is 1 to the 11th. 1. So that's why we picked that number, right? And then we have I cubed, and we're going to get, what was I cubed? -I.
2 to the x minus 3.
2 to the x minus 3.
Yeah, minus 4.
Oh, I love these types of problems. What do you guys think here, all right?
And then we're supposed to label the x and y intercepts.
Let's label the x and y intercept. So you guys know this is a transformation, and you've got to come up with a basic graph. It doesn't say, the basic graph is you have to figure it out yourself, right? So what is the basic graph here that we're gonna be moving?
It's a muffin.
It's
In the
muffin.
Yes, the muffins, English muffins cooking. So it is
11.
x, right? You wanna pick 2, you could pick 3 or 4 or 10. They all look like that, don't they? They all look like that, and they have an asymptote right here at y equals 0. What point do they all go through? 0, 1. Okay, so they look like that. So here's 2 to the x. I'll do it right here. Charles, can you say it?
Damn it, Charles.
And so, here it is. I'm drawing this one. Put that in there too. And then I'm going to do this piece first, Abby. What does that tell me to do?
To move it to the right.
To the right, 3. Okay, so the whole thing's going over 3. So this is staying where it is, right? Anything horizontal is staying. So I'm just going to move it over 3, and it would look like that. All right? And I'm not going to put points in yet because I'm not quite done. And then what do I do?
-4.
Move it
Go
down
down
4.
So what do I have to do with that?
Move it down 4.
So it would be now
-4.
y equals 4. So it's going to be like that. And do you guys agree that's what it would look like?
I do.
And that's not the most pretty graphic, but if I put these 2 points in, it'll be beautiful. All right? Won't it be beautiful once I put those 2 points in? All right. So how do we find those 2 points? How do we find the x and y intercept of
Find
anything?
the x-intercept, we plug in 0 for y.
Okay, so 0 equals 2 to the x minus 3 minus 4. Go ahead. Tell me how to solve
4
that.
equals 2x to
They're
the x minus
separate.
3. And then,
No, they're all
so
different.
it's 4 is 2 squared, so x minus 3 equals 2.
Okay. Charles wants to change 4 to 2 squared. Is that all right?
Yeah.
Okay. So 2 squared equals 2 to the x minus 3.
So that means 2 equals x minus 3.
2. How come, Charles?
Because when the numbers, when the bases of exponents are the same, that means the exponents are equal.
Got it. So we're going to get x is
5.
5. So what does that tell me? What did I do? I put 0 in for y. So the
Yeah.
point, which point's on this graph?
5, 0.
And there it is, 5, 0. Good thing it looks like it's there, is it too, right? And then that's the x-intercept. How do you find the y-intercept?
I'll plug in 0 for x.
Yeah, that one's easy, don't you think? So y of 0. 2 to the 0 minus 3 minus 4. Can we do that?
So it's 2 to the 1/3, right?
That's 2 to the negative. Look at that. So this point right here is 0, negative 31/8. Is that right? Oh, that's a cool number, negative 31/8. Does it look like it's negative 31/8?
Yeah, it is.
Because it's not, it's a good thing it's not bigger than negative 4, right? Because we know it's above there. So there is a beautiful graph of this. There it is. There's the linear. That's probably more realistic, right?
Yeah.
About how many dogs my classes are going to have. Okay.
Could we try like how many dogs you'll have in whatever year? In 2050?
You do the same ones we just did, like
Yeah.
F1 of 38,
But F2 of.
F2 of 38.
84.
So that's more realistic than 3,617.
Yes.
Okay, definitely. All right. Anything else?